Hey y'all, today we're going to talk about circumference and arc length of a circle. To do that, we're going to start by talking about polygons. We've got sort of Olympic rings. I know they're not intersecting, but I just wanted to be on the theme. Go Team USA. A little snowflake for us. USA. Yahoo. Okay, so this is an exercise you could do if I have a circle of a given radius. I could inscribe a polygon in that circle. And I could estimate where I can know exactly, really, if I measured these lines, I can know the perimeter of each polygon. So the perimeter of this triangle is going to be somewhat less than the perimeter of this square, which is going to be somewhat less than the perimeter of this pentagon. And all of these are going to be underestimates of the perimeter of the circle. 8, this octagon is our best estimate for the perimeter. The perimeter of this octagon is our best estimate for the circumference of the circle, but it's not perfect. It's going to get better and better and better if I have a polygon with an infinite amount of sides, and this polygon would be called a circle. So originally, that is a good way of thinking about what circumference is and how it relates to perimeter. Circumference is a synonym for perimeter. It just applies to circles. So that's a lesson there. The circumference. The circumference is the distance around a circle. That's our working man's or working woman's definition for a circumference. There's also this crazy relationship, which is timely given the time of year. We are approaching one of my favorite days of the year, Pi Day. There's a unique relationship between the diameter of a circle and its circumference. And we get that relationship by saying the circumference divided by the diameter is equal to pi. This is the concept. This is how it's spelled. This is a Greek letter pi. It is approximately 3.14159. When we manipulate this around, so let me just C over D is equal to pi. I can move this around and I can say C is equal to pi, and I would typically have D lowercase d. Let me do that real fast. C over D. So circumference is equal to pi d. And here we can see diameter is just the same as 2 radiuses, radii. So if diameter is equal to 2 radii, then C is equal to 2 pi r. And this is the definition of circumference we're going to see, or the equation for circumference we're going to see over and over and over again. But it's very easy to go back to our original equation for circumference. This formula has many different applications. Our first is we can estimate the circumference of a circle with a radius of 3. This is just our first example. So here I've drawn it. So here I've got a circle, or what is supposed to look like a circle, with a radius of 3. Got my equation here. 2 pi r. Okay, so our r should be 3. Let me go back. Get rid of this. I should have made it 3 in the first place. 2 pi times 3, this is the same thing as 6 pi. I want you to pay attention here. Notice this is an equal sign, so that means it's an exact answer. For some reason, students often think, I'm not saying you, but students often think that this is not an exact answer. But pi is exact. It is a number. It is totally exact. And it's an irrational number, so that means it keeps going. So any sort of approximation I use for pi is actually less accurate. So if I say 6 pi, if I want to have a numerical answer, or an approximate answer. I use these wavy equal signs, which says an estimate. And pi is roughly 3.14, So what's going to be 6 times? So we can do that right here. There's 3.14 times 6. I should have had that. Whatever. 4, carry the 2. 6 times 1 plus 2 is 8. 6 times 3 is 18. So this is an approximate answer. So 18.8. Okay, this is in it's just in units. It's not squared because this is not representing an area, it's representing a distance. Okay, here's another maybe more advanced example. I have a BMX bike, and the wheel of the BMX bike has a diameter of 22 inches. If the wheel makes 300 revolutions, how far will it go? So let's go here. Circumference. Let's go to pi. What's my diameter? 22 inches. 22 times pi. I've done this work. It's actually in your book. 69.08 inches is my circumference. So this is, if I were to walk around with the tape measure around the wheel, 69.08 inches. From here back to the starting point. So if this goes around on the ground 300 times, 69.08 times 300 is approximately equal to 20,700 inches, which is approximately equal to, I divide this by 12. This is inches per foot. This is approximately equal to 1,700 feet. Okay, now we've got to talk about arc length. So I've got an orange here. Look at that picture. Wow, such an amazing picture. And I want to estimate if I were to walk, if I was an ant, and I were to walk from here to here, I want to figure out how far I walked. And we're going to say this orange has a diameter of 2 inches. So it has a radius of 1. So how far would I walk? Well, let's say I walk around the whole orange. So that's circumference. We know circumference has a formula of 2 pi r, and my r is 1. So my circumference in this case is 2 pi, which is approximately 6.28 inches. So that's the whole orange circumference. Whole orange circumference. So what about just a segment of the orange, just a slice? Well, how many slices are there? I just want to find this slice. This is 45 degrees. How many 45-degree chunks are in this circle? Got 1, 2, 3, 4, 5, 6, 7, 8. I can divide this by 8. 2 pi divided by 8 is 1 pi divided by 4, which would be our arc length in inches. Another way to do this, let's say you have a more, let's say we've got some random, we say this is 55 degrees, and I want to figure out the arc length of a 55-degree segment. How much is 55 out of 360? I don't really even need to do the math. 55 out of 360 is my ratio of segment to hole. So if I want to figure out the arc length for this slice, I'd go 55 or 360 times my circumference. And what is my circumference? It's 2 pi. So my circumference is, my arc length is going to be 110 pi over 360. So I'm almost out of time. 11 over 36 pi. Have a great day.